Welcome aboard, fellow navigators. You're watching Crypto Navigator, and if you haven't yet, make sure to click that subscribe button for weekly insights into cryptocurrency. Stay ahead of the market with us. Today's topic is very interesting, so let's get started. What is SMV? Originally, blockchains were primarily used as decentralized networks for processing transactions. However, virtual machines have enabled smart contracts to be built on top of blockchains, changing them into foundational layers for a wide variety of use cases and applications. The Ethereum Virtual Machine, EVM, and the Solana Virtual Machine, SVM, are prime examples. In this article, we will explore what the SVM is, how it works, and how it differs from the EVM. What is the Solana Virtual Machine, SVM? The SVM is the execution environment for smart contracts on the Solana blockchain. It can process thousands of transactions per second, TPS, improving the scalability of the network. Ethereum was the first to create a blockchain virtual machine, the EVM, which has since become the standard. EVM's architecture has inspired several blockchains, such as BNB Smart Chain, Avalanche, and Tron, which have developed systems forked or compatible with the EVM. The Solana Virtual Machine has emerged as a formidable competitor to the established EVM. How does the Solana Virtual Machine work? The Solana Virtual Machine, SVM, is like a powerful computer that runs on the Solana blockchain and handles smart contracts created by users. We can break the SVM working mechanisms in a few different steps. 1. Validator nodes. Solana has lots of validator nodes spread out globally. Each runs its own version of the SVM, meaning they can work on different tasks independently. 2. Preparing smart contracts. To run a smart contract, the SVM first translates it into a language that the node can understand. This makes sure that the smart contract is executed correctly. 3. Running the smart contracts. After the smart contract is in the right format, it gets executed. The smart contract updates some blockchain data on the particular node's version of the SVM that runs it. 4. Reaching consensus. This updated version of the blockchain is shared with all the other network nodes to reach consensus. Let's imagine that a user is using a decentralized application, dApp, built on Solana to buy and sell digital art. When they buy a piece of art, a smart contract is executed to update the ownership record on the blockchain. This smart contract is run through the SVM on one of the nodes, which checks the rules, makes sure the payment is legit, and updates the blockchain data. Parallel execution with C-level. A distinct feature of the SVM is its ability to handle many smart contracts at the same time. That is achieved through parallel transaction processing. Essentially, the SVM executes multiple smart contracts in parallel, enhancing transaction throughput and efficiency. C-level is a component of the SVM that addresses the potential conflicts in parallel execution when multiple transactions affect the same account state at the same time. For instance, if two transactions, one adding funds to a wallet and another withdrawing funds, are executed simultaneously, it may lead to computational errors if not managed correctly. C-level is designed to manage dependencies between transactions explicitly. Smart contracts on Solana specify which parts of the blockchain state each transaction will modify. This allows the system to identify transactions that can run independently, affecting different parts of the state, and those that are dependent, affecting the same part of the state. Dependent transactions are processed in the sequential order to prevent any conflict, ensuring that each transaction is executed accurately without compromising data and the blockchain's overall performance. Challenges of the SVM. The SVM faces various challenges. One of the main setbacks is the complexity of maintaining system stability and security in a parallel processing environment. While efficient, this architecture requires additional coordination to prevent conflicts and ensure integrity when transactions that affect the same data are processed simultaneously. In addition, the Rust programming language presents a steeper learning curve for new blockchain developers compared to Solidity and other programming languages used in blockchain development. So the SVM is an execution environment on the Solana blockchain that emphasizes efficiency in transaction processing and smart contract execution. It uses parallel transaction processing and the Rust programming language to enable higher transaction throughput and better scalability. The SVM faces certain challenges, such as the steep learning curve for the Rust language and the inherent drawbacks of the parallel execution model. Still, The SVM's integration with emerging AI technologies promises an increase in its future usage and adoption. This is your captain signing off. If you enjoyed our crypto journey today, make sure to hit that subscribe button and join us again for more updates. Thanks for watching, and keep navigating toward success.